Okay, and we're back. Sorry guys, I wanted to make this one video, but had a little technical problem there. So let's look at probability and area. Before we look at length and probability, now let's look at area. All right, and let's zoom in here on, whoa, on this thing. Okay, probability and area. Let's say I've got I don't know, some random shaded region here. We'll call it. We'll call this random shaded region J. Okay. And then inside it, we've got another random shaded region. How about M? Okay. So we've got M in here. We're going to shade that. We've got J over here. That's another shaded region. They don't necessarily have to be shaded, but we've got two regions. Okay. And what I want to do is randomly pick a point K. Okay, randomly pick a point K somewhere in J. And I want to know what the probability that K is actually in M. Okay, so the probability that K is is in M. Well, that's going to be is going to be the area of M. Okay, the area of the section that we want divided by the total area, which is the area of J. So the general theme here is the stuff that I want, the area of M, divided by the entire area. Okay. Now let's move over here and do an example that we have a target. We have something that kind of looks like a target here. Okay. So let's say I want the probability that I hit the bullseye. Okay, so the bullseye is this inner circle. Let's move over. Okay, the bullseye is the inner circle. And I know a couple things. The radius is, inner circle here is 5. Okay, the radius of the inner circle is 5. The radius of the whole thing is 12. So the radius of the middle circle is 8, but we don't really care about that. The radius of the entire thing is 12. Okay, so to do this, what we've got going on is we've got the bullseye in here in red is going to be our M from the example over there, and then the whole thing is the target. So what we would do is we'd say, well, the probability of hitting the bullseye, and I think you should always write it, write out what you're kind of thinking before you do any math. The probability of hitting the bullseye. Probability of hitting the bullseye is the area of the bullseye. So the area of the bullseye divided by the total area. So we'll just put area of the total area. Okay? And so the total area is the area of the entire big circle here. Okay? So we can find that pretty quick, right? Pi r squared gives me the area of the whole thing. The area of the bullseye, well, we can find that pretty quick too. So let's find those two things real quick. Let's do it in, how about orange? Area of the bullseye well, that's going to be pi times 5 squared, which gives me, let's just leave it as 25 pi Okay, and then the area of total is going to be pi times 12 squared, right? Pi r squared, 12 squared, which equals 144 pi. All right, and so that means the probability of hitting the bullseye equals 25 pi over 144 pi. If it ever loads. Probability of hitting the bullseye is 25 pi over 144 pi. The pi's cancel out. We're left with just 25 over 144. Okay? And that's it. So that's how we find the probability of hitting the bullseye. Now that's if we think about it as if we threw a dart randomly and we had no idea where it was going to land. That's how we would know the probability that it would randomly hit at some point there. Okay. Let's see. Let's look at this next one. The area of the shaded region. I don't know if you can't tell, but the shaded is this stuff in the square, not including the circles. So this stuff here in orange, that's the shaded region. I want to know what the probability of hitting that region is. If I randomly, let's say I randomly threw a dart again. So probability of hitting the shaded region, or the dart landing not in the circle. Okay? Well, the probability of hitting the shaded region, and I really like this notation, I really believe that you should use it and set it up first before you go and try and find, you need a plan for this stuff. I don't think it's particularly difficult, you just got to go at it carefully. Alright, so it's going to be the area of the rectangle minus the area of the circles Okay, so I'm going to take the area of the rectangle. That's the whole thing. But if I subtract out the circles, that'll leave me with the good stuff. That's what I want, the orange stuff. Take the rectangle, take out the circles. Okay, divided by the whole thing. Well, the whole thing is just the area of the rectangle. Okay. Cool. Now, let's actually find these areas. What's first? The area of the rectangle. Well, the area of the rectangle is going to be 8 times 6, right? Which is 48. Okay. The area of the circle, well, the area of the circle is going to be pi, the area, what we really want is the area of both circles, okay? And if we know that the whole distance across the circle here, and I'm going to erase this line in a second, but if we know that blue line is 8, then I know that one diameter is 4, and one radius must be 2, okay? So one of these radii must be 2, and that's true for both circles. The radius of the circles are 2. Okay, so knowing that, right, because so knowing that, I'm going to take pi times 2 squared, that's the area of one circle, plus pi times 2 squared again, right, that gives me both circles, and that's going to equal 8 pi, right, 4 pi plus 4 pi is 8 pi, okay, cool. Now we're just going to actually find the probability. So once again, probability of the shaded region. Probability of the shaded region is going to be the area of the rectangle minus the circle. So 48 minus 8 pi divided by 48. Okay. Once again, if it ever loads. Right, and you'll find that if you put this in your calculator, you get down to the probability is about 0.47. Okay, which makes sense. Now, if you got a probability of 172, that would probably be a problem. You probably made a mistake somewhere. I really hope this loads so you can see what happened here. But if you've got a probability of like 172 or 10 or 11 or whatever, anything greater than 1 or less than 0, then you know that something went wrong. So I don't know if this is going to load or not, and this is as frustrating for me as it is for you. I apologize. But anyway, what we ended up with there, I'll repeat it one more time, is the probability of the shaded equals 48 minus 8 pi divided by 48. Okay, and if you do that math out, you get 47. Okay, and as opposed to making a third part to this video, we'll leave it at that. I was only going to do one more example anyway, so this isn't a huge thing. We'll hit the other example in class. But remember, probability of the good stuff equals the good stuff divided by the whole thing. So that's what you've got to reason through and figure out. And I will try and refresh the page and see if that helps. And it doesn't look like it's going to. Oh, wait. Oh, there it is. There we go. Okay. So that's what we said. 48 minus 8 pi divided by 48 is 0.47. Okay? And then, real quick, the area of the shaded in the circle, this is the shaded here in blue. That's the area of that outer circle, and then, so they're in blue. And then also the area that's shaded in number 8 is these 3 outside equilateral triangles. 3 triangles that are kind of the outside triangles, smaller triangles in number 8. Okay, and that's it for this section. I apologize that it was a little bit longer. Like I said, we'll kind of hit these 2 examples in class, and that'll be it.